All right. Welcome to CSE 222. So there'll probably be people coming in for the next few minutes because it's a big campus, but we'll go ahead and get started anyway. So hopefully everybody's here for CSE 222. The majority of you were in 224 with me last quarter, but there's upwards of a dozen new students who are taking 222 and weren't here in 224. So some of what I talk about will be redundant because you lived, slept, and breathed it in 222, things like one-day programs and service learning project. But we're going to go through some of the sort of administrative details today. I want to talk a little about the 224 final, some reflections from that. And then we'll go ahead and we'll jump into the good stuff. So there's two sections of this course. There's an A section and a B section, 10 o'clock and 11 o'clock. You're welcome to come to either section, okay? I don't know how full they're going to be. I think currently we're well over 60 students. I think this room can squeeze in 35, so we can get up to 70 theoretically. But it's possible the second section will be less crowded. But whatever works for you. I'm going to keep both sections in sync. We'll go over the same material on the same days for the most part, so you're free to pick one or the other. You don't need to change your registration, okay, because they're effectively the same course. So if you do not have Canvas, so how many people here have not officially added the course yet? Okay, so catch me after class and fill out an ad sheet. I have some with me, and we'll get you added in officially. Yeah. And there's an empty chair here that can get moved if somebody else comes in, and then we'll start pulling them out of other rooms. All right, so let me start by just kind of running through some of the information. So you should have Canvas access. If you don't have Canvas access, let me know, and let's get that going. So this is me. If you need to get a hold of me for something that you actually need to talk to me about, like I can't get logged in, I don't have Canvas access, I can't add the course, that kind of thing, go ahead and shoot me an email or catch me in class. So let me run through some of this. Let me see if there's chairs back here. If not, well, there's a stool here. There's one chair in the front row. So finding a spot to sit is another challenge, but at least you don't have to stand. All right, so let me start with the syllabus. I'm not going to read all of this to you, but I want to hit the highlights. So hopefully you already know this is a data structures course. We work strictly in C. We're assuming a high degree of proficiency with C. Okay, that's part of the point of 224. So you don't want to be struggling with things like, how do I write a function? How do I compile a program? How do I pass an array to a function? Things like that. If you don't remember those things, but you've learned them before, right, they'll come back to you quickly. But you want to be pretty comfortable with algorithms, programming in general, C in particular. Things like pointers and addresses of variables and stuff like that, we're going to go over that, okay, because we don't do that in 224. So we're going to spend time learning those elements of C, but programming itself hopefully is getting to be second nature. The textbook is a free download. I don't recommend printing it out, it's really big, but download it, keep the PDF around. And it's a pretty good resource. So there's extra chairs up here. Let me talk about the outcomes. So we're very outcome focused in these programs and courses. So let me run through these outcomes, and a lot of this may not make sense until we actually get to the material, but let me tell you what it is that we're trying to get you through in this course. Abstract data types. Okay, everything that we talk about, we're going to talk about these things called data structures. They're things like linked lists, stacks, queues, trees, hashes, heaps. And we're going to learn how to build these things in C and how to work with them in C, but we're also going to learn these things kind of as an abstract notion. So what's the abstract idea of a linked list versus what's the code we write to build a linked list? So an abstract data type is this idea of forget about the code, what's the idea of a linked list, a tree, a hash, a heap, and so on. Okay, that's your most important takeaway from this course probably, is understanding these data structures abstractly, but also typical implementations and how we use them and such. Select and implement fundamental algorithms and data structures such as ordered collections, queues, stacks, and so on. So knowing the difference between these different types of data structures, when to use them, what the advantages and disadvantages of them are, and so on. That's another intended outcome. And then actually coding them up, so designing them, putting them in code, debugging them, testing them, working with them. Okay, so that's the programming part. And recursion. So if you've taken 215, you've done mathematical induction, that's all that recursion is. If you're taking 215 this quarter, we're going to be doing proofs the first week, and that's going to take us into induction shortly, and that's the backbone of recursion. So recursion is potentially a really strange way of looking at programming, but once you understand it, it's really, really powerful. And we'll see that as we work with some of these more advanced data structures like trees, that recursion is actually your friend. It's not just something that weirds you out. So we'll learn a lot about recursion and compare that to non-recursion, which is what we call iterative strategies. We'll talk a lot about sorting and searching. Those are whole areas in themselves. Lots of different ways to sort data, right? You've learned bubble sorts in other classes, but there's tons of different ways. And why would you use this sort versus that sort? When is this more appropriate? When is this more expensive but somehow better? And so on. So we'll spend a week or so just dealing with sorting and searching. And then ability to work in a team. So we'll have one programming assignment that's a group project. We're also going to have some in-class activities to work on. I'm not going to do labs this quarter. I'll bring the labs back in 223. But we will have some classwork where you'll be working in small groups and doing some real-world debugging. So those are the intended outcomes. Topics to be covered. This is probably fairly accurate, but the details are subject to change, so I'll let you read that. That's a repeat of a lot of what we talked about. Course policies. So academic honesty and plagiarism. If you were in 224, you've heard me talk about this a lot already, but I'll talk about it again anyway. The real goal here is the concern here is not so much you're going to take somebody else's code and turn it in, okay? That does happen occasionally, and that's a huge issue, okay? But the real concern here with academic honesty is sort of the inadvertent thinking that you're doing your own work, but you're really not, right? So you're trying to solve some problem and just can't figure out how to do it, and so you hop online and you go to Google, right? And you pull up some code that shows you how to do what you're trying to do. You're like, oh, okay, that makes sense. And now you write up your program and you turn it in. Once you've seen somebody else's code, you can't unsee it, right? Once you've seen a solution to a problem, you can't forget about it. And when you write your solution, right, you're probably going to some degree, be writing what you just saw, basically copying. Okay. Now the degree to which that happens can vary. If you're, so the Gilligan's Island thing is the standard benchmark. Go watch 2 hours of Gilligan's Island reruns, and then go and write your program, and chances are you'll have forgotten what you've seen. But it's a fuzzy line, right? Because I show you code, the book has code in it. There's nothing wrong with looking at code. The problem is, if you look at code right before you actually write your program or do your quiz or whatever, you can inadvertently be just parroting something that you've seen and not actually learning, and that will show up on the exams, right? And that's not where you want to discover that, I don't really know how to create a structure in dynamic memory, right? I thought I did, but I was just copying what I saw online. So we'll talk about that in some more detail as we go through. But outright cheating is an absolute deal breaker. Okay. The grade you get in this course is almost worthless, right? Obviously, you need to pass the course to be able to move on, and if you're looking at scholarships or admissions to universities, your grades matter. But getting an A versus getting a B in this course versus getting a C in this course is not what you should be most concerned with, right? You really, really, really want to learn the material. If you come out of this course and you understand data structures, you are in really good shape, right? I don't care if you got an A, I don't care if you got a C, I don't care if you squeak through by 1 point, right? Your goal is to understand this stuff, to understand data structures, to internalize these concepts, to be able to work with them. That's what's going to serve you down the road. Okay, that's what's going to make you successful in 223. It's what's going to make you sail through when you get to a university. Well, hopefully sail through, but get through at least. Right? So time is running late, and you're crunched, and your friend's already done the project, and you've helped them out a bunch. You know you can learn this stuff later, so you ask if you can look at their code, and you type part of that in for yourself, right? I may or may not notice it. More often than not, I do notice it. But if this comes up, and if it's noticed, right, it's a big problem. So first of all, it's a 0 on the assignment. If it happens more than once, it's an F for the course. If it happens somewhere else, like WSU, first time, you can find yourself kicked out of the school. Okay, places take this really seriously. And that's not something you want to try to deal with, okay, because now you got to go through this whole process of sort of starting over from scratch. If you're in doubt, ask me, right? I'm really stuck, and I've had students who have done this. They say, I was really stuck, and I looked at this, and I saw a solution, but that's the only way I can think to do it now, and I don't want to just type that in. What should I do, right? And we can work on that. Okay, that's all I'm going to say about that. Late work, no late work other than programming assignments. I'll let you turn the programming assignments in 48 hours late, but it's a 50-point deduction for the first day. Sorry, 24 hours late. But it's half off each day. So plan ahead. Okay, make sure you start your assignments early. If you've got your program done, turn it in, right? If it's mostly done and it's close to the deadline, submit it. You can resubmit it when you finish it up, right? But turn in what you have. I won't start grading until after the deadline, and I'll always look at the latest thing that you've submitted, okay? Don't spend 2 weeks writing something, plan to turn it in an hour before the next morning, and then you find out the power's off in your neighborhood and you can't get your internet to work. And, right, so you lose a bunch of points. All right, support services. If you feel like you would benefit from some sort of accommodation, extended test time, low distraction environment for taking exams, note-taking services, things like that, the DSS office has lots of options for that. And we work closely with them to try to accommodate whatever special needs someone might have to try to make things equitable, okay, to basically put you in a situation where you have the best chance of being successful in this course. And this is true for all courses here at Clark. It's not just this one. So if you have any concerns or questions about that, you can talk to me or you can talk to DSS. And there's different ways to contact them on there. College-wide policies. Let me just read the non-discrimination policy because this one, they're all important. I think this one is particularly worth reading out loud. So. And this is the only time I'll read from a slide to you in this course. So Clark College affirms a commitment to freedom from discrimination for all members of the college community. The college expressly prohibits discrimination against any person on the basis of race, color, national origin, disabled veteran status, sex, sexual orientation, age, gender identity, creed, gender expression, Vietnam-era veteran status, religious, marital status, and presence of physical, sensory, or mental disability. The responsibility for and the protection of this commitment extends to students, faculty, administration, staff, contractors, and those who develop or participate in college programs. It encompasses every aspect of employment and every student and community activity. Okay, so treat everybody here equally, right? The goal is to make sure that you're here to learn some material, you're here to learn some subject, and to build on that and to be able to use that as part of your plan towards further success, right? And the basic goal is to make sure that everybody has an equal shot at that, right? And that there's not things that you have to deal with that are taking away from your ability to learn and to perform and to prove yourself. So we want this to be a positive environment that enables that for everybody. Student Code of Conduct, you can click through to that and read it. Class cancellation, assuming we ever get a winter here, and assuming that comes with some sort of snowfall at some point when we have class canceled, right, it'll be posted on the website, and you should get automatic updates. ECS course policies, you can click through for department-specific information, and there's also a page on Canvas with specific information for this course, this section. So any questions on the syllabus? All right, let me hop through to additional information. So again, we meet 10 to 10:50, 11 to 11:50 is the other section. My office hours are on my door. They're basically 9 to 10 in the morning. But there's a link there to a schedule that has office hours for myself and for Izad. For matters of advising, you can talk to either of us for computer science or engineering. Okay, for questions on this course, you probably want to talk to me rather than Izad. But there's a link to a schedule. My office is 115. It's right on the other side of the collaboratorium. First door is Izad, next door is me. There's my email. Okay, let me talk about emails. If you took 224 with me, you know that I've generally been pretty accessible through email to the tune of 70 or 80 emails a day. I can't keep that up this quarter, okay? So we're going to try to change the methodology for addressing questions. Again, if there's something that you really need to talk to me about, I can't make it to class tomorrow because of such and such, what are we going to study, right? Send me an email. But if you're running into questions on assignments, I wrote my program and I'm sure it's right, but I'm not getting 100% on it, right? I'm going to ask you to start using the discussion area in Canvas, okay? As your first attempt at least. And when you post on Canvas, I get an email about it anyway. And if it's something that I think I should chime in on, I'll chime in right away. But start working more with each other for kind of these general questions. Now, I don't want you to post code and say, can someone fix my program for me? And you say, yeah, here you go, this will work. Don't do that, okay? Here's my program, and I can't get it to compile. It's giving me a compiler on this line. I don't see what's wrong with it, right? I'm okay with that. And if you see what's wrong with this person's code, maybe don't just say, oh, here, I fixed it for you, but say, well, take a look at what you're doing on the line before, because that's where your error actually is, right? Try to help each other out. Helping somebody with stuff is the best way to learn it, right? You think you understand how a queue works, right? But when you start answering questions to somebody else about queues, that's when you really start to figure out, like, oh, I see what it is, right? So it's really useful to you to try to help other people. So take advantage of the discussion area, right? Just go over to discussions and you can start a new topic. All right, so grading. There's going to be 5 long programming assignments. That's 20% of your grade, okay? So 4% each. One-day programs are back. That's going to be 15%. If you haven't had 224, we're going to talk about one-day programs shortly. I've got some online quizzes on Canvas. That's a total of 10%. I'll open those up as we go through, so when we finish a particular set of topics and the quiz covers that, I'll open up the quiz and I'll tell you about it and I'll tell you when it's due by. So those you can do in Canvas, and they're short, 5 to 10 question quizzes. There's several of those. So that's 10% of your grade. Midterm will be 20%, final will be 25, Service Learning project is 10. That should add up to 100. I'm not going to read through all of that. Come to class, try to come to every class, okay? I record the lectures, I post them. There'll be a link on Canvas pointing to a YouTube channel, but that's not the same thing as coming to class, okay? Guarantee we'll never see this many people in this room until the midterm, right? Last quarter, we probably lost about half the class. And then midterm came along, and boom, they all reappeared, right? You cannot get the same experience by just watching the videos, okay? Because the videos are, it's like watching YouTube, right? If I could do that, I wouldn't have to offer a class. I would just make YouTube videos, and you could watch it, and you'd be done. You got to be able to think about stuff and ask questions or respond to questions. It's got to be an active process. And just watching the lecture video and listening to other people's questions is not an active process. So come to class every day as much as possible. And try to stay tuned in, try to stay present, try to think about the material we're going through. I'm recording, I'm posting, so you don't have to write down every single thing that I do. I write some line of code, you don't have to copy it down unless that helps you learn it, right? But the most important thing is when I'm talking about something, are you thinking about it and does it make sense? Or do you have a question? If you have a question, ask. Okay? I prefer the class to be as informal as possible in the sense of if you want to spend the entire class time asking questions, that would be fantastic. Okay, I don't have a preset lecture that I need to get through. You don't need to hear me say 6,000 words on linked lists this morning, right? You need the idea of a linked list, you need to think about it, you need to figure out what those questions are that you have about it, and ask those so that you're following along, so that what we're doing is making sense as we go. So keep it as back and forth as appropriate for you. We already talked about do your own work, but let me talk about these last 3. A lot of what we talk about in 224 is modularization, right? That's just a long word for breaking things into little things, right? Breaking big problems into smaller problems. Taking some big task and breaking it into smaller and smaller subtasks. And we're going to be doing that a lot this course. Okay, the programs you're going to be doing in here can be hundreds of lines of code. You don't want to just sit down and try to write a 500-line program to do some assignment, right? You want to break it into pieces. Well, I have to do this and that and then these 5 things. And start writing code for those pieces. And to do this thing, well, I've got to do these 5 steps here. So break code for those 5 steps and so on. Be thinking about how to subdivide problems. This is the power of programming, right? This is why everybody wants to hire programmers, whether you're doing programming or not, because you're learning how to tackle problems. You're learning how to take big things and put them into smaller things and then put those pieces together. It's a really valuable skill. Get good at writing test code. Okay, I tried to push this through ODPs last time. It didn't always work. But when you're writing code, test your code as you're going. Right, this is another thing you can do if you're breaking problems into smaller problems. Make a small piece of your assignment, test it, test the heck out of it. Spend 20 minutes just throwing different test cases at it. exercise it every possible way you can until you're convinced this is rock solid, right? And now you never have to think about it again, right? Go on to the next piece, do the same thing. When you're building at a higher level and you're taking these pieces and putting them together, you've got confidence that those pieces work correctly. So if your higher level function isn't working correctly, you don't have to be looking at your low level code. You can be looking at, well, how did I glue these pieces together, right? So testing is going to be really important. We're going to spend a lot of time playing with GDB this quarter. The other thing, stick to a Unix environment, okay? I encountered people who are using Visual Studio or code blocks or this or that or something else. Yeah, that makes it a little faster to develop, but you're not learning the Unix side of things, okay? And Unix and C and data structures, they all kind of have parallel structure, and the more time you spend sort of in a Unix realm, the more comfortable you're going to be with a lot of what we're doing in C. All right, exams, closed book, open note, 4 double-sided pages allowed, same as last time. Late programming assignments, okay, 25% penalty for the first 24 hours, 25 for the second, and then nothing after 48 hours. So turn your assignments in on time. All right, that's all I'm going to say about that. Any questions on any of that? We still have our network and all that that entails. All right. While I was thinking about that, let me talk about the Service Learning project. So, and there's a link on Canvas, but it's not going to let us get to Canvas right now. Service Learning project is basically a large, ideally year-long project of your own choosing that you're going to pick yourself and you're going to work on throughout this course. And if you take 223, throughout 223, and if you took 224, you started in 224. If you did not take 224 and you're just starting this course right now, I need to post something in here that helps you out. So I'll post a link by the end of today under Service Learning Project that basically describes the idea of the SLP. Basically, it's a project you're going to pick on your own, decide what you want to do, and you put together a timetable and you start working on it. And the last Tuesday of each quarter, there's a presentation where you basically present your work to whoever wants to come by and see it. So I'll post a note on that. And then you can ask me if you have questions on it. But I do want to talk about the presentation. So the presentation is basically a poster show. So your final submission for this quarter for your SLP is a one-page poster that basically highlights the different aspects of your work. And then the last Tuesday, which is March 12th in this case, from 3 to 5 in the Digital Lounge, there's a presentation. And basically, you're going to find a place to sit. You're going to sit down with your poster. People are going to walk around, come over and talk to you. Okay? This is mandatory. Okay? The only exception, and I wish I could bring this up because I don't want to tell you something that's not true, but I might have to. All right. Well, you can read the section on SLP presentation. But if you absolutely cannot make it because you've got work, because you've got some kind of conflict, and you know that like March 12th, 3 to 5 is not going to work for you, you got to let me know this week. Okay? If I don't have it from you in writing by Friday that you're not going to be able to make the presentation, you're going to be expected to be there. Okay? And if something comes up, then I understand that, but you won't get points for the presentation. Okay, so you've got to think about this and either explain to me right now why you can't make it, or make sure that you keep that time free down the road. All right, well, without a network, it's going to be hard to talk about service learning project or one-day programs. But let's see. Maybe we can get lucky. All right, no joy. So we'll talk about other stuff. So the machine we use for this is linux.engrcs.com. And your username, so my name is Nick Macias. My username will be my first initial followed by my last name. And it's however your name appears in Canvas, as of a few days ago at least. So if your name is hyphenated, then that would be my username. Okay, it's all lowercase, there's no punctuation unless there's a hyphen in your name there. If that's your name, it's first initial, last name. Okay. And your default password is your student ID followed by an underscore. So 1, 2, 3, 4, 5, 6, 7, 8, 9 followed by an underscore. No spaces or punctuation in the student ID, so it's 9 digits followed by an underscore. And the first time you log in, it'll ask you to put in your current password, and then it'll ask you for a new password twice. If you don't have an account, if it doesn't seem to understand you, if you can't get logged in or something like that, shoot me an email. That's a good email question, and I'll get that set up for you. If you run Windows, the most popular way to connect to the server is probably PuTTY. Mm-hmm.
Our passwords from
if you're in 224, I haven't changed anything, so you should still be good. If you're on Windows, the most popular way to get connected is probably PuTTY, and you want to make an SSH connection. If you're on Linux, you can just do SSH, your username at server. If you're on a Mac, there's you should be able to do SSH also from a terminal window. Yeah.
If we have SSH keys on our account from last quarter, will it still work?
That should still work, yeah. Oh, good. Okay. All right, so for me, my username is nmacias. I'm going to SSH nmacias at linuxengrcs.com. I've got it set up with what's called an SSH key, so it's not going to ask me for a password, but normally it'll ask you for a password, and you just put that in. But we've lost our connection. Okay. Let's see who's logged in. One person. All right. So let me talk about one-day programs. So you don't learn how to program by listening to me talk about programming. Okay, that doesn't work. And you don't learn about programming by looking at programs. The only way that you learn programming is by writing programs and testing them and finding they don't work and figuring out what the error is and fixing them and so on. It's an active process, okay? It's like weightlifting. You can go to the gym, you can watch people lift weights, you can read weightlifting magazines, you can watch videos. You're not going to build muscle. The only way you build muscle is by going and lifting weights. It's exactly the same thing with programming. The only way you learn to program is by writing programs, okay? And there's always this tension because 70 people in the class, and if it takes me 15 minutes to grade somebody's program, right, that's like 17 hours. of grading, right? So can I do that every week? Probably not. Can I do it every 2 weeks? Yeah. But if I only give you 5 programming assignments, there's a percentage of students who will basically not work on the assignment until the 2 or 3 days before it's due, which means you might have 10 days worth of material that you don't understand, but you didn't know you didn't understand it because you didn't start trying to use it, right? The other end of the spectrum is I give you an assignment every day, and I spend 17 and a half hours every day grading your programs, and that's not feasible. So I use a system called one-day programs, and these are small programming assignments that you can write and they get graded automatically. Okay, so there's an online assessment system. You write your program and you use the assess command and it will grade your program for you. Okay, and the goal of the one-day programs, the ODPs, is really to give you a chance, in some cases every single day, to test your understanding of where we are in the course, to sort of force you to keep in step with where we're going. So we'll talk about some concept related to structures, and then there'll be an ODP that says, okay, here's what you need to write, a piece of code that uses structures. And if you're keeping up and if you're understanding the material from the lecture, then the ODPs might take you a few minutes to do. Okay? If you don't understand the structure, it might take you a half hour, it might take you an hour to do an ODP. That's time that you're spending learning what it is that you need to learn about structures or pointers or address dereferencing or stacks or queues or whatever, right? But it's kind of forcing you to do this in a way that lets you keep up with class, so that the next day when we get to class, we can start building on that. So ODPs are generally going to be posted by 8 o'clock in the morning, okay? Which means that, you know, possibly you have some time to look at it before class, possibly not, depending on your schedule. But generally, when there's an ODP posted, we'll spend the beginning of class time talking about the ODP. And I'll give you some information that will help in doing it, and I'll ask for questions on it. That's the time to be thinking about the assignment, okay? Don't just say, you know, I'll watch the video later and see what the teacher said, and then start looking at the ODP 10 o'clock at night, because that's where I get 70 emails coming in, right? Had some feedback from students saying they wanted 2 days to work on the ODP so that they had time to look at it and then come in and ask questions during class. I want you to think about it while we're going over it in class, okay? And we're going to go over the first one in a minute. But when we go through the assignment in class, that's when you want to be thinking about, okay, do I know how to do this? And if it's not clear, if it's like, wait, I don't know how to do this because I don't know how to pass arrays to functions, right? That's the time to ask, okay? And this, I think everybody who's had classes with me would agree, this is generally a safe environment to ask questions, right? I'm not going to call somebody out and say, you should have already learned this. You know, that's a silly question. I'm not going to answer that, okay? I don't do things like that. It's uncomfortable sometimes to, you know, especially when everybody else looks like they're confident and they know what's going on. It's uncomfortable to feel like you're the one person who doesn't understand, and to put yourself out there and say, you know, I'm confused, right? I hated doing that when I was a student, but sometimes you got to do that. And guarantee everybody who's sitting around you who looks confident, like they totally understand, not all of them do, right? When I was in graduate school in mathematics, I discovered nobody knew what the heck was going on. But everybody was like, you know, well, yeah, of course, you know. And I thought I was the only one. No, everybody. All right, so there's a link here to a video that talks you through using the assessment system. But let's just go ahead and run through this as an example right now. So for the first few of these, I'm going to post the information on this on Canvas, but eventually I'll just have you read it out of a file on the server. So ODP 201, this is an initial test. It's kind of like a hello world, okay? And this is typical of what you'll see in these assignments. You're going to be asked to create a function to do something, okay? So in this case, your function is something called sum. It takes 2 integers, it adds them, it returns the sum, okay? That's not hard to do. Okay, the reason for doing this assignment is to make sure that you know how to build this thing, how to link it in with the main program, how to run the assess command. Okay, so, and I'm giving you 2 days on this one. This one's due Wednesday, because I know some people don't have accounts set up yet on the server and so on. So you're going to create your program, sum.c, but to make an executable program, you're going to link it with a precompiled main program, which is /temp/main.o. And so we're using our regular GCC command, make the output file main. It could be anything you want. Here's the precompiled main program that I'm giving you, okay, main.o. Here's the program that you're creating, sum.c. So this main.o, this is a test bed. Okay, this is the thing that's going to use your function and try to determine if it's written correctly or not. So you're going to write your function, and for this, you know, there's only so many ways you can write a function that adds 2 arguments and returns a sum. But generally, you want to test this yourself first. You want to write your own main program that calls sum, I don't know, call sum 5, 7, store the result in x, and then print out x, make sure it's a 12, right? And then go ahead, link it in with the test bed, and this will give you an executable program, in this case called main. And then to assess it, you say assess, and then the name of the executable, and then the name of your source code. And people from 224 have forgotten this because lots of people have been running this trying to assess with the name of the source file in both cases and so on. So it's assess, the name of the executable program, and then the source code file. So let's do this. If I can keep a connection long enough. I don't think I can. It's possible the network is actually in worse shape right now than it was last year. I hope not. Okay, so I've already cheated. I've already written my horribly complex function here, sum. So it takes 2 integers a, b, it returns their sum. And I should make a main program that tests this. That's not going to work. All right, so you're going to have to try this at home where you have a network connection or Starbucks or something. But assess main sum.c, and it'll give you a short list of like 3 commands you can use. Basically, you want to use the command uppercase G for grade. Okay, and it will go ahead and it will test your program, and it will give you something out of 10 for each of the tests it runs. Hopefully you get 10 out of 10 on each. Yeah?
So it accepts just command line arguments? Or just any?
No, you say assess like that, and then it gives you a little prompt, and it's like GDB, you put in commands inside the assess program. And you can do this as many times as you like. Okay, whatever the last time is that you ran it, that's the grade that'll get recorded. Whatever the last time was you ran it at the point where the assignment is due. So in this case, Wednesday morning, 8 o'clock.
That doesn't record a highest grade.
No, it's the latest grade. So if you got it to work and you got 10 out of 10, and then you are curious about something, so you try breaking your code and you run and you get 0 out of 10, and then you don't do anything else, you're going to end up with a 0. Okay, so make sure the last time that you ran it was the one that you got 10 out of 10 on. And if I have to, I can fix that if it happens, but it's better not. All right, so there's a link to a video that basically shows you what I would show you if I had a connection right now. It's like a 10-minute video, and that's the assess command. If you do not have an account, right, send me an email as soon as possible, and I'll set that up for you on the Linux server. And you have to do this from the Linux server. That's the only place the assess command is set up. And if you haven't done this before and you did this and you're not sure that it worked or something, you can shoot me an email and say, hey, I think I did this and I got 10 out of 10. Can you check and see if it worked? And I can check the logs and the grades and stuff like that. So I gave you 2 days on this just to sort of work out the initial growing pains on it. But try to do this like as soon as possible today. so that if there's issues, we can talk about it tomorrow. Does that make sense? So it'll be a series of one-day programs, and I'll generally release them 8 in the morning. We'll go over them in class, and then they'll generally be due the following morning at 8. And everything automatically turns on and turns off based on the clock on Linux. So it's out there, it's just really slow. All right, we only have like 3 minutes left. So the other thing I wanted to talk about was the 224 final. And I've got this posted on Canvas, so you can read through it, but it's not necessarily self-explanatory. But it's things like this, right? So these are just things I saw on the final that aren't wrong, but they're indicative of maybe there's a different way you could be thinking about things. For example, a line of code that says return followed by the word else, right? You don't need that word else, right? If this statement gets executed, right, this return statement, you're not going to come down here to this next line of code, right? It doesn't do anything. If I equals 0, do some stuff, else if I is not equal to 0, do some stuff, else do some other stuff, right? So this else is not necessary here, because if I is equal to 0, you're going to do this. Or you could just skip the if I equals 0 and say else, because if I is equal to 0, you're doing this block. If you're not doing this block, it must be that I is not equal to 0, right? So this I not equal to 0, you might put in a comment, right? But it doesn't have to go in code. And this last else block is impossible. This is never going to fire, because either I is 0 or I is not 0, right? So this makes me wonder, and would make, someone in an interview, for example, wonder what your thought process is, right? What your understanding of conditionals is, and so on and so forth. So we'll talk through some of these tomorrow. I don't want to spend a lot of time on it, but take a look at them on Canvas and ask questions if you're not sure what I was asking. And otherwise, we'll go through that tomorrow.
So my previous class was in VHL, and there's just a milk crate in math books. I was wondering if just by random happenstance I happened to grab a discrete math book that was similar to this.
Cool.
So I don't know, is that what they look like? Just mathematical structures, or is this?
Yeah.
Okay. Because I saw that there were like AND gates and stuff in the front reference guide, so I was like.
Yeah, so this is pretty close to 215.
Okay, awesome.
Some stuff we won't cover in 215, and a few things we might cover that aren't in here. But yeah, this is pretty good.
Awesome. And then for the internet, this is not something I want to say in front of everyone, but what I found to work to get me really good signal access when everyone else is getting kicked off for some reason.
Yeah.
Oh, okay.
When I run through mine through a VPN, not only do I not get kicked off as often, but my speed goes way up.
Really?
I don't know what's going on there. So,
okay.
But if I tell everyone that, then that might.
Then it might stop working.
Yeah.
Okay.
We do. We see. How'd you do on maintain physics? B+. Hey, nice job. I passed barely with C. Do I want that? Everyone goes to it. That's